Hello, this is Mr. Stansbury. I'm going to take you through the notes on inverse variation. At the end of this, you should be able to say, I can show that two variables can be inversely proportional, and I can find a formula connecting the variables. Okay, so first things first, two variables are inversely proportional, or vary inversely, if one variable is multiplied by a constant, then the other variable is divided by the same constant. Okay. So with that, if y is inversely proportional to x, then y would be directly proportional to 1 over x, so the inverse of that. Okay, so we would write that as y varies directly with 1 over x. So what you could do is write that as y equals k, our constant, right, times 1 over x, which is k over x. So if you multiply both sides by x, we get xy equals k. Okay, now this is kind of all the idea behind the formula. Here's the quick and easy as to how to do this. Example 5. Suppose y is inversely proportional to x and y equals 20 when x equals 6. Here's the quick and easy on how to do this. Okay, so we would want to make ourselves a little chart here, and x and y. Okay, so it's not inversely proportional to the square of x, or it's just plain old x, right? So it says y is 20. Whoa, I don't know what happened there. 20 when x equals 6. Okay, then it says for a, find y when x equals 18. Now, you can go through and do this whole inverse proportional thing, but here's the deal. If two variables are inversely proportional to each other, the fastest and easiest way to do this is to multiply these two together, because if you'll remember, let me turn this off for a second here, we know that x times y will equal our proportionality constant there. Okay, so basically what we want to do is we want to multiply x times y. So if we do 6 times 20, that gives us, let's see, 6 times 2 is 12, 120, right? So here's the deal. 18, like every time you multiply these things together, you're always going to get this same constant k of 120. So that means that now if I take 18 times whatever y is, it has to also equal 120. So we simply set this up as 18 times y equals 120. So we divide both sides by 18, and that will tell us what y is. Okay, so we do 120 divided by 18, and we get 6.67, we'll call it. So this is going to be 6.67 rounded off to 3 significant figures. Okay? Okay, so let's do a quick little comedy break here, and then we'll do the last one here as well.
The ultimate, though, in looking like an idiot is when you walk into a spider web, right? Because nobody else sees that spider web. They just see you walking off in the distance, suddenly flipping out for no reason whatsoever. You know, you're just walking along, everything's fine, all of a sudden, no! Hey, did you see that guy? Yeah, he just snapped. He was walking along, he just went nuts near that tree. Look, he's still doing it.
All right. Let's take a look at B here. So we're going to use this, suppose y is inversely proportional to x and y equals 20 when x equals 6. Okay, so we'll have this, we can use the same thing all set up here. We got our x and our y, right? And then we know still that when x is 6, y is 20. Now it's saying find x when y equals 7. In fact, let's just leave that blank so we can fill it in there in a second, when y equals 7. So again, we know that 6 times 20 is 120. So we know whatever this x is up here, we know that x times 7 has to equal 120, right? We'll put the x back in there. We'll just erase it and make it happen. So we know that x times 7 also has to equal 120. So we simply just divide both sides by 7, And that'll tell us what x is. 120 divided by 7. 120 divided by 7 gives us 17.1, we'll call it. Okay, so now we can take that out, and we now know that that has to be 17.1. Okay? All right, that's all we have for inverse variation. If you have any further questions, please feel free to ask in class. Thanks.